Okay, hey, I'm back. Still with this power supply. And I'll give you just a quick overview. I know this is going to be like the fourth part. So this cap, this guy right here, all right, comes in after this AC comes in here. If it's going through a transformer here, I think they're stepping it up a little bit. Or this is some type of coil stopping any transients current. So, you know, wish I had the schematic to this. But anyway, so AC comes in, they rectify it, and then this guy filters. All right. Now, at some point, they're going to switch the that DC, and so I put this up on the other videos. So AC comes in, they go through a bridge rectifier, which happens to be this guy right here. I know it's probably hard to see, and it may not be focusing on, but it's this guy right here, this long. This capacitor is that filter right here. This filter right here. And then they oscillate that DC. Okay, how do they oscillate that DC? Well, they have to have a chip that's going to take that DC and oscillate it. Okay, and that chip on this guy lives right here. Okay, and that chip happens to be this guy right here. It is an LD7552, and excuse me, and here they're kind of showing you, you know, here's the wall, here's that bridge rectifier, here's that capacitor, and then they're switching it on and off with a MOSFET or an enhanced MOSFET, I think, has a diode out the output. And so you you get this thing to start turning on and off this MOSFET, and that turns on and off the current going through one side of the transformer. And so when you have current going through one side of the transformer, and all a transformer is a coil of wire, you create a magnetic field. I mean, current has to be moving in time. If it's constantly flowing, you're not going to have a magnetic field. So it has to be switching on and off. And so this is how they do it with this chip, this LD7552. And so then it creates a magnetic field on this side over here. And then it goes through some type of rectification. And in this case, I think the rectification happens to be this bad boy over here. And I know, look, I can't, I'm not going to take this out. I can't read the numbers on this, but I did test it. It's a three-legged, it's three-legged, and I unsoldered all the legs. God, I think I did it at school, or I could have done it here, I can't remember. And this tests exactly like a diode. You read, as a matter of fact, this pin and this pin right here are all connected to the same. And so you read, I can't remember if you read from this, say, this pin to that pin, and you get like 0.7 or something. And if you change the leads, you won't get. So it basically reads like a diode. Anyway, okay, so then what happens is, let me go back to the block diagram. I'll be going back and forth here. So then what happens is, here's that transformer, they're switching it with that chip, with this guy, okay? And they're switching it, and it's creating a magnetic field on this other side. It's going through some diode or rectification, and then they filter out any little changing in current, and that's done with these capacitors right here. Okay, and then there's an inductor, an inductance right here, inductor going out to the output. These two pins right here are positive, and these are negative. And all this inductor here does, an inductor like this one on the output there, if current drops real quick, it stops the spike from happening. Okay, that's basically what an inductor does out of here. You know, this may be doing the same thing on the input, but man, it really looks like it's like a toroidal type transformer being stepping up. All right, now the next thing they have to do is well, you have to monitor the output somehow, because if you don't, it'll run away. It'll start you know, if something goes wrong here with the switching, with this guy, let's say something goes wrong here, and this thing starts switching faster and faster and faster and faster, then what starts happening is you get more induced voltage on the other side of this transformer, and so your output voltage here goes up, and so then you can fry whatever's connected to it. Okay, just won't be good. So what they do is they take a feedback and they do it through what they call what is this called? A photocoupler, or optical oscillator is what they do it with. You can't necessarily just take this and come back into this guy, because then you're going to have a short. Bottom line, okay? And so this is a photo oscillator, and so they monitor this, and if this starts getting too fast, and right here they're comparing it. This is a comparator right here. So they're comparing the switching here coming in, and if it gets too fast or whatever, they tell this guy, hey, turn off. Turn this off, turn the power off, that's it. Just turn it off. Okay? So that's kind of how it's a safety feature built in. Okay? Otherwise, if this goes haywire, you'll end up burning up these diodes, or these Zener diodes out of here. Now, and that's, again, this is the block diagram, rectification. Now, sometimes they use, like I said, they use an enhanced MOSFET here that has a diode. Let me just show you what it would look like. And so this guy right here, this is an N-channel enhanced mode field effect transistor, and there's a diode right in there. And this guy happens to be that guy right there. Okay, and that guy right there is what they're switching before here. This is the output over here before this, right? And that guy's being switched with this bad boy down here. Okay, now out here at the output over here, they have this in this power supply. They have a what they call an operational amplifier, and they're using this as a comparator. And so the optical oscillator, and it's going to be real hard to see. I don't know if I shine the light in here. Yeah, it makes everything go real dark there. It's way in here, and I just you know, it's way down in here. It's way down in here. So, all right. So what did I find? I put this guy in, which is new. Okay, plugged it into the unit, and it was still not working. It's you know, so more than likely this capacitor that I put out, you know, which I think on the other part 2, I tested this guy, and it tested within the plus or minus 20%, and the series resistance was really low. It was like 0.7. So this is still a good what do you call it, capacitor, but I went ahead and put a new one in there. Yeah, I'm just going to leave this new one in. Okay. All right. $2. All right. All right. Now, there was 2 capacitors that I didn't check, and they were right here. One's here and one is right next to it. All right. So let me show you what I found. This one that I've already replaced, I have it on my unit here, and I hope you guys can see. And it's supposed to be a 10 microfarad, and it's at 3.6. I mean, that's way out of the limit. So, you know, it's a plus or minus 20%. So 10 times 0.2 is like 2. So the lowest reading we should get here is 8, more or less. And the highest reading we should get for the capacitance is 12. And we're getting 3.64. So it's totally out of the tolerance. Then if we look at the equivalent series resistance, or in this case, these guys just call it series resistance. It's 670.64 ohms. God, that's like way too much. You know, this guy only had 0.7. All right, and that's more like what you have. Yeah, you know, 1 ohm and less than 1 ohm, you're good. Okay. So I've already replaced that one that's here. I've already replaced it. I don't know if you guys can see the leads there. the leads. I'll cut them off right now, but I've already replaced that one. Okay, now where does that one go to? That one goes to the oscillator. Okay, so it makes sense. This thing was like, you know, I could hear it clicking real quick, click, 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 click. And so these capacitors, if I'm not mistaken, they set up the frequency of switching with this chip, you know, it sets up the switching. So let me put the other one on, the other capacitor that was right, and oh, and this happens to be a 10 at 50 microfarads. The other one is the same thing. So let me switch it over. All right. So that's the little bad boy that is bad. Bad boy. Let me put this one on. And this one, okay. So if we look at this one, the capacitance is at 81.6. It's still, let it settle here. All right, let's just go with 78 nanofarads. It's like nano is 10 to the negative 9, so it's not even in range. Okay, right? Because milli's 10 to negative 3, micros 10 to negative 6, nanos 10 to negative 9. So yeah, we're way off. And then look at the series resistance on that. It's 28.6 kilo ohm. You might as well just put a resistor in there. Okay, so that guy is bad. And guess where that one goes to also? To this, what do you call it? They call this the pulse width controller. Okay, pulse width controller, switching this guy off, switching the current on the primary side of this transformer and stuff. So, you know, I'll replace them. I'm gonna, you know, cross my fingers here, hope that they're bad. I know they're bad, okay, but I hope that cures our problem. Now, could something else be bad? Could this diode be short? I've already checked it, and it didn't check short. And I also checked this guy, and there was no short. Again, could this fail under load? Sure it can. You know, could this N channel enhanced mode field effect transistor, you know, under load, could it go bad? Sure. But I'm hoping that these solar capacitors there will do the job and fix it. I'm gonna leave this in. A friend of mine was here yesterday evening while I was working on this, and he asked me, he says, so what would you charge somebody to repair this? Because, you know, I had told him, I said, this whole unit costs $68, $69 off of Amazon. I think you can buy one off of eBay also for about the same price, and shipping, tax, and all that comes out to, I don't know, 80 something bucks, right? Well, you definitely would charge for the capacitor that you put in there. These guys happen to be 36 cents. These small ones, they're 36 cents each. This guy was the most expensive one, like $2 and something. So I would charge probably like $30 labor, and then plus the parts. Okay, that would be a fair deal, because you're not going to charge them. You know, you're not going to charge them $80 plus the parts, because if you're going to do that, you might as well just put a brand new one in, right? So, anyway, okay. So let me move this stuff out of the way. Put all this stuff out of the way. This guy, both of these capacitors that are here, they're both 10 microfarads at 50. Now, I only had one, and the second one I have is at 63 volts at 10 microfarads. So let's check it out. I know the voltage is a little bit more, but the thing is that this is not going to charge up to 63 volts. It's only going to charge up to whatever voltage is being fed to that circuit. Okay, so can we safely put this in there? Sure. All right. So I'm more concerned about the what do you call it? The capacitance. All right. So let me just make sure. Yep, 10 microfarads. All right. Let me just make sure on these guys that I looked at that put on my glasses. Yep, 10 at 50 and 10 at 50. All right. So let's put this one on and let's see where it comes out. All right, so this is reading 9 excuse me, 9 microfarads at like 14 ohms of series resistance. It's a little high, but I'm going to go ahead and put it in and let's see if it works. And I want to say this one, the one I already put in, that's in here right now, it read like about the same thing. It was about 9 microfarads, and I think the series resistance was I don't know, it was down there. It was, you know, I don't even know if I wrote that down. Let me see if I wrote it down. No, I didn't write it down. Yeah, and I don't want to necessarily. Yeah, I don't want to necessarily unsolder it. So, all right. So let's go ahead and solder this in, and then we'll plug it in and see if the thing works. I mean, that would be really cool if it did. Now, they definitely have a negative. It's usually white with the little line through it, and it's the shorter, when you buy them, it's the shorter lead is negative. Okay, now if they're cut like this, you're going to have to look at the side here. That's negative. All right. Now, how do you know what's negative here on the board? I know you can't see, but I'm going to draw it here on. I'm going to draw it in the back of one of these guys right here. The way you know is it's on the board. They'll draw a circle. I know you guys can't see that, but I'll show it to you in a second. They'll draw a circle, and then they'll have one side and so they'll have one side with like a dark mark, and that's the negative side. Okay. Sometimes they'll actually even put a plus and a minus. Okay. But if it's not, it's like this. And so you know that negative goes to that side. All right. I'm going to go ahead and clip these leads right now. So, by the way, yeah, when you're clipping leads, you definitely want to put your hand over the leads if they're small, because when you clip them, they'll take off. And this happened to me one time. I was working on a unit and I'm clipping leads, and I was clipping small. You know, they were sticking out real small, and I just wanted to clip off probably about 2 millimeters. And when I clipped it, that thing took off and went inside a unit. Thank God the unit wasn't on, and so I had to shake the unit out until that piece came out and stuff. So definitely you gotta be real careful when you're clipping these guys. Here I'm just holding onto them, and they're in my fingers. Okay, so yeah, gotta be real careful with that. All right, so let's put this guy in. That's negative. It's on that side. All right. So now I'm going to put it here. Just this thing will hold it for me. This guy I don't need it on anymore. I'll go ahead and just put these away. Leave here. Alrighty, let me get this over here. And I'm sorry that I'm not zooming in and stuff and y'all can't see You know, some guys have like cameras that are real close and stuff like that, and I don't have that. I guess I could use my phone. Alright, so solder, you clean the tip, and then you add some solder to it. And then you definitely want to, the etches are all these green little, look like little etching little tracks or traces, and then you definitely want to put the iron on the etch, and then so that you heat up the etch and up against the wire or the lead of the unit. And that's it. It's pretty quick. All right, let me do the other one. Okay. And then again, you clean, and then you add some solder to it, and then you put it up. Okay, so I'm just going to check again to make sure these guys are all right. I'm going to clip these guys. And so there's, you know, pretty much I have checked all the caps. I replaced this one, I replaced those two in here. I know it's hard to see. These all checked good. And so I'm hoping this thing will power up and work. All right, so let me move some stuff here. This is the plate that this goes on, and I think we put it on like so. Yeah. Okie dokie. And then put this guy on here. Okay. All right. I'll come back when I got it going. Okay. Okay, so right now when I'm going to check it, I just plugged in the power. I'm checking it no load condition, and I'm going to see what happens. Okay. So let me plug this in here. And that goes down. Okay, so I am not hearing the clicking anymore. All right, and it's at a steady 12.29 or 12.3. Before it was fluctuating, it was like 12.4, and it's just like fluctuating. So I'm hoping this is the fix. Okay, so let me go ahead and power down. All right, and then I'm gonna plug this guy in right here, just like so. Yep. And hopefully what will happen is that when I power it up and I measure the voltage will be constant over here at 12 volts, and then we can I'll put the unit back together, turn it over, and I'll show you that it's working. So I'm hoping that's gonna be the issue. So let me just change my leads here. I don't know. I'm about 100% sure that that I fixed it, but you never know. It's one of those things, you know, under load, the unit may not work. Could be some other issue. All right, here goes. I'm gonna power it on. Okay. And now I'm gonna, hope you guys can see that right there. Oh, I got lights on already. I know y'all can see the lights. Woohoo! So it's working. Okay, so let me plug this in. Yep, there it is. So it's under load, and I'm getting 12.29, and it's fixed. Power supply's fixed. Pretty cool. All right. So, you know, I don't know. I'm one of those, in a lot of my other videos that I've done, I'm a, you know, I used to repair stuff like that, well, home and car audio, and down to the component level like this. Now it's just, we're such a throwaway society that you know, no one's repairing this stuff down to the component level. And typically what goes wrong with these are capacitors. Okay, do you have to have the gear? You know, can you have this one or a handheld one? Handheld capacitor, inductor, resistance analyzer, sure. This one's like, I think you can still pick this up. I picked this up through Amazon, but I think you can pick it up on eBay, and the price has gone up. I only paid like $130 at the time, but this one, it's gone up to like, I don't know, 150, 160. And there's different brands, and this one works fairly decent. This one was $400 and some. It's you know, it's nice. The one that I have at school, the Sencor, yeah, that was like $4,000. They don't make it anymore, but to get something of that caliber, you'd have to spend at least $4,000, $3,000. Do you need the rest of the gear? Do you need all this stuff? Yeah, you know, you gotta have some experience in doing that. So, in a nutshell, I mean, you know, and I'll be totally honest with you guys. At school, I really thought, when I took this to work, I really thought this was a guy that was bad. And these guys, I never checked. And I think if I would have checked them at school first, this thing would already be repaired and stuff. But these guys were bad. Okay. So, and again, I found a mistake in 39 cents a piece. One of them was 39 cents, and the other one was 89 cents. Let me see. Yeah, the 50 at 10 was 39 cents for Mosier. They're not a sponsor. And I want to say this one's 10 volt at 63. I think this one was maybe like 42 or 43 cents. Again, from Mosier. So, alrighty. So let me put it together, all the screws, and then I'll test it one more time, and we'll see that. All right, be back. Okay, so I'm back. I'm laughing because I had put bad, and the way you take it off is you take, this is a permanent marker that I wrote on here with, and the way you take it off is with some, really denatured alcohol is better because denatured alcohol doesn't leave, but this is 70% isopropylene alcohol, and you, let me see if I can do this right here in front of you guys. So you just do that, and you know, you keep doing it until you take it off. It's going to leave some rests, you know, a little bit of the you're scribbling on there. So I'm just going to put repaired, and I'll change the date to, yeah. So anyway, thought I'd show you guys that. Alrighty. Oh, that's a Milwaukee. God, what model number is this? Milwaukee number 6546-1, or catalog number. 2-speed screwdriver, and it's pretty cool. Okay, and it's an inch pounds right here. I had it at 1 inch pound right there, and I think that's tight enough. I mean, I don't know. Let me go back and just check to see how. Yeah, it's. Could they be a little bit tighter? Yeah. I'm tightening them just a hair more. Maybe I should have done it like at 3 inch pounds or something, or 4 inch pounds. It's good enough. You don't want to gorilla tighten these things. So, all right. So now we can put this guy here. Put that guy there. Put this guy over here. Put that guy there. I kind of marred these because I was trying to see if sometimes these are very thin, and you can just take a screwdriver and mark, and then it'll show where a screw is, and then you can pull it out. You can not pull it out. You can tear the that cover right there where that screw is. But this was really hard, and these I've already put more double-sided tape on the feet. So, and hopefully, well, I've already showed you guys it works, but I'll connect it here just to make sure. All right, so that's that. Everything is good to go here. And now we can plug it in. AC power cord. Get this up, and we're going to plug it in. Got to give it some time, and there it is. It's up and running. Cool. Fixed. All right. So the church will have an external DC power for this. That was $32 with tax, and then of course I don't charge the church. But they'll have that one, and then obviously, they already have the AC line cord over there, and again it was what, $2. Just to recap, $2 for this guy, $2 something, and then these guys were like 39 or 40 cents a piece. 39. One was 39 cents. The other one I think was 46, 47 cents. So that's it. I don't know. Hope this helps people out there in the real world, and it's a shame that we live in such a throwaway society, and a lot of that stuff is making its way back to the landfills, and but I don't know. That's we're not teaching that anymore in high school and stuff. And I know junior colleges, I don't think they're doing stuff like that anymore. I don't know. I should probably go and look. We have a typical college. What is it? STC, South Texas College or something. I should look online, and maybe they do have a course where students learn how to repair electronics like this. But all right. See you guys in the next video. Have a good one.